Hi everyone. In this video we are going to see how to find out the coordinates of the foot of perpendicular drawn from a point on a line and also the coordinates of the point's image in that line. In the diagram, I have a straight line A whose equation has been given as ax plus by plus c equals 0. That's the general form of the equation. And we have a point P whose coordinates also have been provided as x sub 1, y sub 1. So here the known numbers are a, b and c from the equation of the given straight line, and also x sub 1 and y sub 1, which are the coordinates of the given point P. Now what do we have to find out? Well, we have to find out the foot of perpendicular drawn from the point P onto the line A, and let's assume that the foot of the perpendicular is the point Q, whose coordinates can be assumed as x sub 2, y sub 2. Those are unknowns, of course, that we have to find out. And also let's assume that the image of P in this line is R, and let's assume that the coordinates of R are x sub 3, y sub 3, and they are also unknown. We have to find out the values of x sub 3 as well as y sub 3, and we have to find out the values of x sub 2 as well as y sub 2, and that is our task. So first we'll try to solve for x sub 2 and y sub 2. Now since PQ is a perpendicular onto this line, then the product of the slope of PQ and the slope of the line A would be equal to -1. I have already created a separate video on this topic. I have shared the link in the description. Feel free to watch that video. The product of the slopes of two perpendicular lines is always equal to -1. So from this diagram, let's first try to find out what is the slope of the line A, and then we'll find out what is the slope of the line segment PQ. Line A's equation has been given as ax plus by plus c is equal to 0, and from here if we convert this into the y equals mx plus c form, the slope intercept form, then can we write it as b times y is equal to -a times x minus c, and from here if we divide both sides by b, then we get y equals -a over b times x, of course, and minus c over b. And here we can clearly see that the slope of the line A is -a over b. That's the slope. Alright, so we have found the slope of the line A, and let me make a quick note here. I'm going to say slope of A is equal to -a over b. Now let's try to calculate the slope of the line segment PQ, and that will be very easy. It will be y sub 2 minus y sub 1 over x sub 2 minus x sub 1. And since PQ is a perpendicular onto this line A, then the product of their slopes will be equal to -1. So product of the slope of the line A, which is -a over b. So from here we can say that -a over b times the slope of the line segment PQ, and this will be equal to -1. That's the product of the slopes of two perpendicular lines. Now if we simplify this little bit, what do we get from here? Let's first multiply both sides by a -1, then we will have a over b times y sub 2 minus y sub 1 over x sub 2 minus x sub 1 would be equal to +1, and then from here if we bring x sub 2 minus x sub 1 onto the right hand side, then on the left hand side we are going to be left with a over b times y sub 2 minus y sub 1, and on the right hand side we are going to have x sub 2 minus x sub 1, and from here again if we bring a onto the right hand side, then on the left hand side we are going to have y sub 2 minus y sub 1 over b, and that will be equal to x sub 2 minus x sub 1 over a. And if we rewrite this, we can write it as x sub 2 minus x sub 1 over a is equal to y sub 2 minus y sub 1 over b, and let's assume that this is equal to k. Now from here let's try to find the value of x sub 2 and y sub 2. So from here we can say, well, then x sub 2 minus x sub 1 over a is equal to k, and from here we can say x sub 2 minus x sub 1 is equal to a times k, and from here we get x sub 2 is equal to x sub 1 plus a times k. And similarly let's also solve for y sub 2. So we have y sub 2 minus y sub 1 over b is equal to k, and from here we can say then y sub 2 minus y sub 1 would be equal to b times k, and from here we can say that y sub 2 would be equal to y sub 1 plus b times k. And now if we look at the diagram, you will see that x sub 2 and y sub 2, they are the coordinates of the point Q, which also lies on the straight line A. That means the straight line A contains this point Q. That means Q's coordinates must satisfy the equation of the straight line. So that is another important concept that we have to understand, that if a straight line contains a point, then the point's coordinates must satisfy the equation of the straight line. So here let's now try to plug in these values of x sub 2 and y sub 2 in the equation of the straight line A. Equation of the straight line A is like this. It is ax plus by plus c equals 0. And if we plug in these values of x sub 2 and y sub 2, let's see what happens. So from here we can say a times x sub 2 plus b times y sub 2 plus c is equal to 0. I simply used x sub 2 and y sub 2 in place of x and y, and then from here we are going to plug in the actual values of x sub 2 and y sub 2. So it would be a times x sub 2 is actually x sub 1 plus a times k, and then plus b times what is the value of y sub 2? Well, that is y sub 1 plus b times k, and plus c is equal to 0. And if we remove the parenthesis, what we get? We get a times x sub 1 plus a squared times k plus b times y sub 1 plus b squared times k plus c is equal to 0. And from here let's isolate the k terms first. So we have a squared times k plus b squared times k plus we have a times x sub 1 plus b times y sub 1 plus c is equal to 0. And from here can we say that k times a squared plus b squared is definitely equal to negative a times x sub 1 plus b times y sub 1 plus c. And from here we can say that k is equal to negative of a times x sub 1 plus b times y sub 1 plus c over a squared plus b squared. Alright, now we have found the value of k in terms of a, b, c and x sub 1 and y sub 1, and all of those numbers are known numbers. Now if we use this value of k right here, if we use that value of k right there, then we can write that equation as x sub 2 minus x sub 1 over a is equal to y sub 2 minus y sub 1 over b, and that is equal to k, which is actually negative a times x sub 1 plus b times y sub 1 plus c over a squared plus b squared. From here let's try to solve for x sub 2 and y sub 2. So we are now going to try and solve for x sub 2 and y sub 2. So we can say that x sub 2 minus x sub 1 over a is equal to negative a times x sub 1 plus b times y sub 1 plus c over a squared plus b squared. And if we multiply both sides by a, then what we get? Well, then we will get x sub 2 minus x sub 1 is equal to negative a times this quantity a times x sub 1 plus b times y sub 1 plus c over a squared plus b squared. And if we transpose x sub 1 onto the right hand side, then we get x sub 2 is equal to x sub 1 minus a times this quantity, and that is the value of x sub 2 in terms of all the known numbers. Similarly, if we solve for y sub 2, let's see what happens. So y sub 2 minus y sub 1 over b is equal to negative a times x sub 1 plus b times y sub 1 plus c over a squared plus b squared. If we multiply both sides by b, what do we get? We will get y sub 2 minus y sub 1 is equal to negative b times that quantity. And from here we can say that y sub 2 is then equal to y sub 1 minus b times that quantity. So we have been able to find out the coordinates of the point Q, which is the foot of the perpendicular drawn from the point P onto the straight line. If we go back to our diagram, we'll notice that Q is nothing but the foot of the perpendicular drawn from P onto the straight line A. And we have been able to find the values of x sub 2 and y sub 2 in terms of all the given numbers. So let's make a quick note. So you can say that Q's coordinates are kind of like this. So Q's coordinates can be written as, let me use a different color. So Q's coordinates can be written as, first let me write down the value of x sub 2, which is actually x sub 1 minus a times, and I put a comma, then I'm going to write the y coordinate, and that is actually y sub 1 minus b times that quantity again. Next we are going to calculate the coordinates of the image of point P. Let's take a look at the diagram again. The image of the point P has been noted here as the point R, and we have assumed that the coordinates of the point R are x sub 3, y sub 3. Now if you think about it, since R is the image of P in this line, the given straight line A, then definitely PQ will be equal to QR, because image is always at the same distance as the object. So the distance PQ will be same as the distance QR. That means Q would be the midpoint of P and Q. Now P's coordinates are x sub 1, y sub 1, and R's coordinates have been assumed as x sub 3, y sub 3, and Q's coordinates have already been calculated. Now if you think about it, that Q is the midpoint of the line segment PR, and that is the concept we are now going to use in finding the values of x sub 3 and y sub 3. So let me make a quick note again. We have P's coordinates which have been provided as x sub 1, y sub 1, and Q's coordinates have already been calculated, but still let's assume that they are x sub 2, y sub 2, and now we have to calculate the coordinates of the image R, whose coordinates have been assumed as x sub 3, y sub 3. And since R is the image, so we can say the distance PQ would be equal to the distance QR, because image is always at the same distance from the mirror as the object. So the distance between the mirror and the object is equal to the distance between the mirror and the image. So from here we can say that Q is the midpoint on PR. From the formula of midpoint, we know that the coordinates of Q being the midpoint, coordinates of Q would be like this. And while calculating the coordinates of the foot of the perpendicular, we saw an equation like this. Now here I am going to use the values of x sub 2 and y sub 2. So let's try that, and let's try to solve for x sub 3 and y sub 3. So now I am going to take the first equation, which is x sub 2 minus x sub 1 over a is equal to negative a times x sub 1 plus b times y sub 1 plus c over a squared plus b squared. And here let's substitute the value of x sub 2. So then we can write it as x sub 1 plus x sub 3 over 2 minus x sub 1. I'm simply using x sub 1 plus x sub 3 over 2 in place of x sub 2. So wherever I had x sub 2, that's what I have replaced with this new value. And of course we already had the minus x sub 1, so I'm keeping that as is. And we also have over a, and that is equal to negative a times x sub 1 plus b times y sub 1 plus c over a squared plus b squared. And from here, if we simplify this little bit, we can say, okay, so all of this is over a, and then here what we get? Well, here we get x sub 1 plus x sub 3 minus 2 times x sub 1, and that is over 2 is equal to this quantity. And from here, can we write it as x sub 3 minus x sub 1? We have one positive x sub 1 and two negative x sub 1s, right? So it would be x sub 3 minus x sub 1 divided by 2 and divided by a. So we can write it as x sub 3 minus x sub 1 over 2 times a is equal to negative of this quantity. And if we multiply both sides by 2 times a, then what we get? Then we get x sub 3 minus x sub 1 is equal to negative 2 times a times this quantity. And from here we can say, well, then x sub 3 is equal to x sub 1 minus 2 times a multiplied by this quantity. So we have found the value of x sub 3, and similarly we are going to find the value of y sub 3. Now y sub 2 is equal to y sub 1 plus y sub 3 over 2, and then we are going to use that value of y sub 2 in this equation here, in this equation right here. Let me highlight here. So I am going to take this part of the equation, and we are going to substitute the value of y sub 2 that we have found over here. So now let's try to solve for y sub 3 then. So we had y sub 2 minus y sub 1 over b is equal to negative this quantity, and the value of y sub 2 was y sub 1 plus y sub 3 over 2. So here I am going to substitute the value of y sub 2 like this. So from here we can say that y sub 2 is actually y sub 1 plus y sub 3 over 2 and then minus y sub 1, and that quantity over b is equal to negative this quantity. And if we similarly simplify this, we are going to get y sub 1 plus y sub 3 minus 2 times y sub 1 over 2 times b, and that is equal to negative this quantity. From here what we have, well, y sub 1 is 1 positive and 2 negative quantity, so that will be resulting in 1 negative y sub 1. So it would be y sub 3 minus y sub 1 over 2 times b, that will be equal to negative of this quantity. And from here if we multiply both sides by 2 times b, then we get y sub 3 minus y sub 1 is equal to negative 2 times b multiplied by that quantity. And from here we can say then definitely y sub 3 equals y sub 1 minus 2 times b multiplied by that quantity. So we have been able to find the value of y sub 3 as well. That means we have been able to find the coordinates of the image of the point P, and that image is actually the point R, and we have been able to find the coordinates of the point R. So let me make a quick note here. So the coordinates of the point R would be like this. It would be x sub 3 comma y sub 3. Now what is the value of x sub 3? That we have calculated already. So x sub 3 is actually x sub 1 minus 2a times that quantity. So let me write it down, and then I put a comma, and I am going to write the value of y sub 3, that is y sub 1 minus 2 times b multiplied by that quantity. So we have been able to find the coordinates of the image R as well. And if you carefully look at the coordinates of Q and coordinates of R, the only difference you are going to notice is this extra 2 right here. This extra 2, let me underscore here. So this extra 2 right here, that is the only difference between the coordinates of Q and R. So let me quickly make a note of the coordinates of Q here as well. And also if you carefully notice that we have been able to express the coordinates of Q and R in terms of all of the known numbers like a, b, c, x sub 1, y sub 1. Those are the 5 known numbers, and using those numbers we have been able to come up with the coordinates of the foot of perpendicular, which is the point Q, and the coordinates of the image, which is the point R. Let's take an example. Suppose we have been given the equation of a straight line, which is, let's say, 2x plus 3y plus 5 is equal to 0, and we have been given a point P whose coordinates are 1, 2, and we have to find the coordinates of its foot of the perpendicular drawn from this point P onto the given straight line. So let's assume that is Q, and also we have to find the coordinates of the image of P in this line, and let's assume that is R, and let's also assume this is x sub 3 and y sub 3. Let's quickly solve this. So we know the coordinates of the foot of perpendicular, their x coordinate, let's say x sub 2 here, we can say x sub 2 is actually equal to x sub 1 minus a times that big quantity, like a times x sub 1 plus b times y sub 1 plus c over a squared plus b squared. And if you carefully see that this is actually a, so our a is right here, so let me say a is actually the positive 2, and b is actually the positive 3, and c is actually the positive 5. And similarly x sub 1 is actually the positive 1, and y sub 1 is actually the positive 2. So let's plug in those values here. So this will be equal to, what is x sub 1? Well, that is 1, minus what is a is actually 2, so that would be 2 times a is 2, x sub 1 is 1, plus b is actually 3, and y sub 1 is 2, plus c is actually 5, over a squared plus b squared. So it would be 2 squared plus 3 squared. And let's simplify this little bit. So that would be 1 minus 2 times. In the numerator we have 2 plus 6 plus 5. So that would be 13, over we have 2 squared plus this square, that's 4 plus 9, that's 13 again. Well, looks like we got lucky. So here this will simplify to 1 minus 2, and that is equal to negative 1. So this is the value of x sub 2. And similarly let's calculate the value of y sub 2. Well, y sub 2 would be equal to y sub 1 minus b times that quantity, and let's plug in the values here. So y sub 1 is actually positive 2, minus b times, what is b? B is actually positive 3 times. We have the same quantity which actually reduced to 13 over 13. So let me write it down again. It would be a times x sub 1, so that is 2 times x sub 1 which is 1 plus b times, that is 3 times y sub 1, that is positive 2, plus c which is 5, and over, that is 2 squared plus 3 squared, and if we simplify this, then we get 2 minus 3 times, in the numerator we have 2 plus 6 plus 5, that is 13, so 13 over 4 plus 9, that is also 13, so 13 over 13. Here again looks like we have 2 minus 3, and that is equal to negative 1. So here again we got the negative 1. So the coordinates of the foot of the perpendicular have been calculated already, and it turns out to be negative 1 comma negative 1. So here I am going to write simply right here negative 1 comma negative 1. Right below the x sub 2 and y sub 2, I have written the coordinates of q, which is negative 1 comma negative 1. Now let's try to calculate the coordinates of r. For coordinates of r, I am going to write it like this. X sub 3 is equal to x sub 1 minus 2 times a times that quantity, and if we plug in the numbers, we have x sub 1, that is actually 1, minus 2 times a is actually 2, so that is 2 times 2, and times that quantity. We have already seen twice that the quantity is 13 over 13, so I am simply going to write 13 over 13, and that will be equal to 1 minus 4, and that is equal to negative 3. Alright, so we have found the value of x sub 3. Now let's calculate the value of y sub 3. So we can say y sub 3 equals y sub 1 minus 2 times b times that quantity, and if we plug in the values, we have y sub 1 is actually positive 2 minus 2 times b. What is b? Well, b is actually positive 3 times that quantity which is 13 over 13, and that is equal to 2 minus 6, and that is equal to negative 4. So we have been able to find the value of y sub 3 as well. Alright, then we can simply write the coordinates of the image r as negative 3 comma negative 4. So we have been able to find the coordinates of the foot of perpendicular, which turned out to be negative 1 comma negative 1, and also we have been able to find the coordinates of the image of this point, and that point is r, and its coordinates turned out to be negative 3 comma negative 4. I hope everything made sense. Thank you for watching. See you in the next video.